All right, so today is December 3rd, 2014. The topic we're going to cover is prime factorization. The objective is to generate equivalent numerical expressions using order of operations, including exponents and prime factorization. The essential question that you should be able to answer at the end of the lesson is, how do you write the prime factorization of a number? The first section we're going to cover is finding the prime factorization of a number using the factor tree method. First, we have to understand, what is prime factorization? Well, it is a number written as the product of only its prime factors. A factor tree is only one method we can use to find the prime factorization of a composite number. How I like to teach factor tree, or help you remember what the factor tree is and how it works, is think of it as a cherry tree. If you see here this picture, you see lots of cherries, you see some leaves, but more focus on the branches. You have a branch here, and then you have the fruit. Do you see any branches growing out of the bottom of the fruit? No, you don't. Because branches don't grow out of the bottom of the fruit. Once the fruit has been made, that's it. No more branches come out of the cherries. So I want you to keep that in mind. We're going to use the factor tree to find the prime factorization of 12. So we start with our composite number 12. Since it's a composite number, branches are going to come out of the composite number. So I'm going to draw two branches coming out of 12. Well, now I have to figure out what two numbers multiply together to give me 12. Well, what do you think we can use to figure out what factors we can start our factor tree with? If you said a factor T, you are correct. You can make a factor T to figure out what are the factors of 12. We have 1 times 12, 2 times 6, 3 times 4. And if you write 4, you'll be repeating, so that means these are all your factors of 12. One thing you must remember about a factor tree: only composite numbers and prime numbers belong on the factor tree. Can you tell me what number is neither composite or prime? If you said 1, you are correct. 1 is not a composite number, and 1 is also not a prime number. So since it's not a prime or a composite number, it does not go on our factor tree. So now that we know that 1 does not go on our factor tree, we cannot use the factors 1 and 12. So we can either use 2 times 6 or 3 times 4. For my example, I'm going to use 2 times 6. So I'm going to write the two factors on the end of the branches. So now I have 2 times 6. Do you see a prime number? Yes, you do. We see 2. And since 2 is a prime number, I'm going to make a cherry out of it. So I'm going to circle it to indicate that it's done. Remember, branches do not grow out of the fruit. So once I've circled my prime number, that means I'm done with that part of my factor tree. Now let's go over to 6. 6 is not a prime number, it is a composite number, so that means I'm going to draw two branches coming out of my composite number. Again, what two numbers multiply together to give me 6? 2 times 3. I see another 2, so I know that's prime. So I'm going to make a cherry out of it. But I also see 3. Is 3 a prime number? Yes, it only has two factors, 1 in itself. And since 1 does not belong on the cherry tree, that means we are done. Oh, I didn't mean to do that. That means we're going to make a cherry out of the 3. Do we have cherries at the bottom of our factor tree? They're all cherries. All the numbers are now circled. Since all the numbers are now circled, that means we're done with our factor tree because branches cannot grow out the bottom of our cherries. So that means the prime factorization of 12 is 2 times 2 times 3, or 2 to the second power times 3. Let's do another practice problem together. We're going to use the factor tree to find the prime factorization of 240. Again, that's a pretty large number. So I want to do a factor tree just to make sure that I know all the factors of 240. I start with 1 and just keep going until I'm done or I don't repeat myself. So there's a lot of factors to choose from to start our factor tree with. So I'm going to start our factor tree with 5 times 48. So here's the completed factor tree for 240. We know 5 times 48, but 5 is a prime number, so we would make a cherry out of it. And as you can see in our factor tree, all the prime numbers are listed right here and at the bottom. So that means we can circle all of the prime numbers. Now that all the prime numbers are circled, there's no more branches coming out the bottom, so that means we're done with our cherry tree. But what if I've used a different set of factors to start off with instead of 5 times 48? Let's see what happens to our factor tree. We still have 240 as our large composite number. I used 2 times 120. And then we worked it out. And as you can see, we have our factor, our prime numbers that we need to make cherries out of. So again, I have 4 2s, 1 3, and 1 5. Let's look over here. 4 2s, 1 3, and 1 5. So even though we started off with 2 different factors for 240, we still come up with the same prime factorization of 2 times 2 times 2 times 2 times 3 times 5, or 2 to the 4th power times 3 times 5. I forgot to put that 3 right there, so sorry, that's my bad. So you would do 2 to the 4th power times 3 times 5. So the prime factorization does not change even when you start off with 2 different factors. Here's another method that we use to find prime factorization of numbers. This method is called the ladder diagram. It's another way to find prime factorizations of a number. So here we're going to find the prime factorization of 132 using the ladder method. So the first thing we're going to do is write 132 on the top step of the ladder. Now that we have 132 on the top ladder, what you want to do is write a prime number for 132 on the outside of the first step. So what prime number can we use that multiplies to another factor to give us 132? Well, since 132 is even, we know it's divisible by 2. So I'm going to put 2 on the outside of my ladder. Well, when you have 132 and you divide it by 2, you get the number 66. So that's our next composite number. So now we need to choose a prime factor for 66. So what prime number can we multiply to another factor to get 66? Well, we know 3 can be divided into 66, so I'm going to put 3 and 2. So I'm going to put 2 on the outside, which will leave me with the composite number 33. You just keep repeating that same process of choosing a prime factor, dividing, and adding it to the ladder until you get a quotient of 1. So now, what can I divide 33 by? That's a prime number. Now I'm going to use 3. And 33 divided by 3 is 11. The only number that I can divide 11 by is 1 and itself. So I'm going to put 11, since it's a prime number, on the outside, and I end up with 1 on the bottom of my ladder. So the prime factorization of 132 is 2 times 2 times 3 times 11, or 2 to the second power times 3 times 11. Again, remember, we only want to use prime numbers in our prime factorization. So 1 does not go because 1 is not a prime number. Here are your 3 practice problems. Your first practice problem: complete a factor tree and a ladder diagram to find the prime factorization of 54. Then I want you to tell me, what is the prime factorization of 54? You can write it in expanded form or exponential form. Number 2, use a factor tree to find the prime factorization of 402. So I want to see you use the factor tree and then tell me, what is the prime factorization of 402? Number 3, use a ladder diagram to find the prime factorization of 32. So this one, I want to see a ladder diagram and then tell me, what is the prime factorization of 32? For all of your answers, you can either put them in expanded form and put them in exponential form as well. If you need to re-listen to any part of the video, please stop, go back to the beginning, re-listen to it, but make sure that you have the understanding of how to find prime factorization using either the factor tree method or the ladder diagram.